Hi, thanks for joining me. Today I've got an interesting problem to do with people meeting each other at a party. Suppose we have a party of 25 people, and it has the property that if you take any 3 of those people at the party, then out of those 3, there's at least 2 people who know one another. So it could be that they all know each other, or there's just 2 people who know each other out of those 3. Anyway, we want to prove that there is someone at the party, or at least one person at the party, who knows at least 12 other people at the party. Okay, so if you want to have a go at this problem, pause the video now and give it a go for yourself, and I'm going to jump straight into a solution. Okay, so let's first consider the trivial case, and that's the case where everyone at the party knows everyone else. Now this certainly satisfies the conditions, because if you take only 3 people, because everyone knows everyone, those 3 people will know one another, so certainly out of those 3 people, at least 2 of them know one another. So that satisfies the conditions, and then to solve the problem, show that there's at least one person who knows at least 12 people. Well, just take any random person you want, and they're going to know the other 24 people at the party, and certainly 24 is at least 12, so that solves the problem. It's kind of trivial, and it's not too interesting. The interesting case is when there are at least 2 people who don't know one another. So let's take any 2 people who don't know one another, call one A1 and the other one A2, like so, and we're going to label the other 23 people at the party A3 all the way up to A25, like so. Now we're assuming that A1 and A2 do not know one another, and what I'm going to do here is draw on a little table, like so, and what I'm going to do is list down the friends that A1 has at the party and the friends that A2 has at the party, so the people that each of these guys know, and I claim that at least one of these columns will have at least 12 friends, and that will solve the problem. And the way we're going to do that is exploit the property that out of every 3 people at the party, at least 2 of them are friends, or at least 2 of them know one another. So let's first consider A1, A2, A3. Now, because A1 and A2 do not know one another, it must be that either A3 knows A1, or A3 knows A2, or potentially A3 knows both of these people. In which case, we're just going to write A3 under the corresponding column. So if A3 knows A1, we'd write A3 here, and let's suppose A3 also knows A2, so we'd write A3 there as well. Then what we're going to do is consider A1, A2, A4, and do the exact same thing. Because A1 and A2 do not know one another, either A4 knows A1, A4 knows A2, or A4 knows both. In which case we're going to write A4 under the corresponding column, so let's suppose now A4 only knows A1. Okay, so A4 will only know A1, and it doesn't know A2. Okay, so we put A4 there, and we continue this argument with A5, A6, all the way up to A25. So we're going to have, an A3 row, an A4 row, an A5 row, an A6 row, and so on, all the way up to A25. So there are going to be 23 rows. Now, because of the pigeonhole principle, at least one of A1 or A2 will know at least 23 over 2 people. Because if that wasn't the case, suppose A1 and A2 had less than 23 over 2 friends, or 23 over 2 is just 11 and a half, so they have less than or equal to 11 friends. Well, that would imply that this sort of table would have less than or equal to 11 plus 11, which equals 22 rows, but that's not possible because there are clearly going to be 23 rows, each corresponding to A3, A4, A5, and so on, all the way up to A25. So that tells us that there must be at least one of A1 or A2 which has at least a 23 over 2, so at least 11 and a half friends. But of course you can't have half a friend, or at least I hope you can't, so that means that they must have at least 12 friends at the party. So there's one of these guys, potentially both, that has at least 12 friends. And I guess the case where you can think of a case where they both have at least 12 friends, in the case where you have everyone at the party knowing each other, except just these 2 people who have never met before. Anyway, I hope you have enjoyed this problem. I enjoyed it, certainly. It uses the pigeonhole principle very nicely. And yeah, I guess the key thing was noting, or sort of using the condition that out of every 3 people, at least 2 of them know one another. Anyway, thank you for watching. I'll catch you in the next one. Have a great day.